Hello everyone, I'm your winning student Jericho Manalo. You are now on the last presentation regarding the sampling, and I want to thank you for staying until at this moment. Since we are done discussing the different sampling designs, we, as the researchers, should now focus on the second aspect of the sampling design issue. And ano yon? That is the sample size. Basically, the sample size is the representation of the whole population, right? Pero ang problema dito, how do we determine the appropriate sample size na gagamitin natin sa research? Kunwari, we select 20 people from a population of 1,000 through a simple random sampling procedure. Tanong, will we be able to generalize our findings to the population with confidence, given na pinili natin yung probability design that has the most generalizability? Another question, what is the sample size required to make reasonably precise generalization with confidence? And yung bang 20 dun sa example natin is fair enough to make a good conclusion for the study? Also, since kanina pa sila nababanggit, ano nga ba yung meaning ng precision and confidence sa research? But before proceeding to the main discussion, please take note of this. According to Sekaran and Boogie 2016, there is no sample statistics is going to be exactly the same as the population parameter, no matter how sophisticated the probability design is. Lagi nating tandaan na ang ginagawa lang ng mga probability designs na na-discuss ng mga previous reporters is to increase the probability na yung sample statistics will be as close as possible dun sa population parameter. Nakuha ba yon? If we're good, then let's start now on what precision and confidence are. First, precision. It refers to how close our estimate is to the true population characteristics. What does it mean? For example, from a study of a simple random sample of 50 of the total 300 employees in a workshop, we find that the average daily production rate per person is 50 pieces of a particular product. With that given scenario, pwede nating sabihin na yung true average daily production of the product lies anywhere between 40 and 60. Dahil doon, we offer an interval estimate, just like kapag hindi tayo sure kung magkano ba yung product na gusto nating bilhin. Kumbaga, may allowance, which is in this case is 10, plus or minus 10. Pero for instance, if we want to estimate na yung population mean will fall anywhere between 45 and 55 instead na 40 and 60, then we have more precision. Kasi habang nagiging narrow yung range ng estimation natin, mas nagiging precise tayo. Look on the simple illustration I made. Ayan. Mas precise yung pangalawang x-axis kasi mas kakaunti yung allowable margin of error niya kumpara dun sa unang x-axis. In short, mas malapit sa sample mean natin. Now, may dinagdag ako na another term dyan na feel ko is itatanong nyo din sa akin, and that's accuracy. It is always compared kasi sa word na precision, and actually, both are important factors to consider when taking data measurement. But when talking about accuracy kasi, it reflects how close a measurement is to a known or accepted value. Yung precision naman, on the other hand, reflects how reproducible measurements are even if they are far from the accepted value. And kapag sinearch mo sa net, yung dalawang yan, may isang illustration na magdi-differentiate sa kanila. And yun yung paglalaro ng darts. Ayan nga, dun sa screen natin ngayon, if titingnan natin, we have 4 boards with different landings ng mga darts, which is yung kulay yellow na small circles dyan. Sa board A, obviously, it presented low precision and low accuracy. Like, tumira ka lang kasi required ka sa PE na maglaro kahit na wala ka naman talaga sa mood maglaro. Kasi gusto mo ikaw yung pinaglaruan. Joke. In board B, it had a high accuracy but with low precision since yung mga darts are not that much closely to each other. Oppositely naman, sa board C, it had a high precision but with low accuracy because they are far from the center point, which is yung main target natin. Meanwhile, sa board D, it is the one precise and accurate. Yung darts from the center point indicate high accuracy, and darts being close to each other indicate high precision. And this is the ideal one for researchers. Ideal, meaning a standard of perfection. To understand or to remember these concepts, sabihin na lang natin na if you are precise, doesn't necessarily mean that you are accurate. However, if you are consistently accurate, you are also precise. And in as much that we want to be accurate, it is not possible in quantitative research since we are just taking samples unless itatest mo lahat ng nasa population. If you observe sa news about sa vaccine na yan, meron ba nagsabi na 100% effective? And kung meron man, paano nila nasabi, di ba? Kasi according din sa International Organization for Standardization o yung tinatawag na ISO, accurate measurement has no systematic error and no random error. So essentially, ISO advises that accurate be used when a measurement is both accurate and precise. Okay? In addition to precision, before tayo tuluyang tumungo sa confidence, introduce na natin yung isang formula na magagamit natin hanggang sa pagkuha ng sample size. Because precision, it is a function of the range of variability in the sampling distribution of the sample mean. So, medyo malalim yung range of variability. Ano ba yung meaning ng range of variability? That is, if we want or if we take a number of different samples from the population and take the mean of each of these, we will usually find that they are all different and have dispersion associated with them. So, the lower this dispersion or yung variability, the greater the probability that the sample mean will be closer to the population mean and vice versa. Kaya kung makikita nyo dyan, nilagay akong 2 arrow, habang bumababa yung variability, tumataas yung precision. If you recall dun sa x-axis natin kanina, mas precise yung, mas narrow yung range. And with that, need natin na di gaano magkakalayo yung mga agwat ng mga data. And the variability is called the standard error, or yun yung may pa-plus or minus 10 tayo kanina kung natatandaan nyo, dun sa sample mean. And the standard error is calculated by the following formula. Yan yung nakikita nyo dyan sa box na yan. S subscript x mean is equal to S, or the standard deviation, divided by the square root of n, or yun yung sample size. And take note din na yung standard error varies inversely with the square root of the sample size. kung gusto natin na mabawasan yung standard error given a particular standard deviation in the sample, then need nating increase ang ating sample size. Okay ba yon? Okay. Now, let's move on the confidence. It denotes how certain we are that our estimates will really hold true for the population. From the word itself, it is an expression of how confident a researcher can be. Balikan lang natin yung example natin kanina sa precision. We know that we are more precise when we estimate the true mean population to fall somewhere between 45 and 55. Kesa dun sa somewhere between 40 and 60. It is because the narrower the interval, the greater the precision, right? However, we may have more confidence in the latter estimation than the former. Kasi 'di ba, mas lumaki yung chance natin na tama yung magiging estimation natin doon sa 40 and 60. And if we want to have a higher level of confidence, then we need to sacrifice some precision. Ganun naman talaga lagi, 'di ba? May dapat magparaya. That is why there is a trade-off between precision and confidence for any given sample size na madi-discuss later. But for now, just remember that confidence has an inverse relationship towards precision. Also, dagdag ko lang, confidence levels are expressed as a percentage. Di ba? 100% confidence, ganon. Pero yung 95% confidence is the conventionally accepted level for most business research. Most commonly expressed by denoting the significance level as P is less than or equal to 0.05. In other words, we say na at least 95 times out of 100 na yung estimate natin will reflect the true population characteristics. Now, again, precision and confidence are important issues in sampling because when we use sample data para mag-draw ng inferences or interpretation about the population, gusto natin na fairly on target at meron tayong idea doon sa extent ng possible error. And because point estimate provides no measure of possible error, ang ginagawa natin is interval estimation, gaya nung kanina, di ba? So, kasi we want to ensure relatively accurate estimate of the population parameter. And technically, gumagamit tayo ng statistics usually using C or T table. Before tayo mag-start sa problem or sa example na nakalagay dyan, bigyan ko lang kayo ng idea when to use C table and T table. As per my research, we normally use T table when the sample size is small and yung kino-consider na small dito is less than 30. Also, T-table pa rin when the population standard deviation is unknown. Bale, unang tanong talaga is if known ba yung population standard deviation. Kasi kung hindi, diretsong T-table ka na. Kahit na yung sample size mo is above 30. By the way, since kanina pa din nababanggit yung standard deviation, just in case hindi pa nasabi ng mga previous reporters kung ano yon, it is a measure of the amount of variation or dispersion of a set of values. May formula tayo rito and sinosolve din ito. Meron ding dalawang types of standard deviation, which is yung population standard deviation and sample standard deviation. Kapag population standard deviation, fixed value yan na calculated from the individual. I mean, every individual in the population. Kapag naman sample standard deviation, it is statistic, meaning calculated from only some of the individuals in a population, kaya sample. I hope clear tayo doon. Going back dun sa example natin, it says that you want to estimate the mean dollar value of purchases made by customers when they shop at department stores. From a sample of 64 customers, sampled through systematic sampling design procedure, you may find that the sample mean is equal to 105 and the sample deviation is 10. So what we will going to do here is to find the population mean and look at the difference as we use different confidence level. And yung population mean is computed as the sum or the difference of the sample mean, denoted as X, and the confidence interval, or yun yung the product ng standard error and the statistics. In short, the U-like sign dyan, yun yung population mean, is equal to the X plus or minus K, yung statistics natin, multiplied to S subscript X mean. And we already know how to solve for standard error as mentioned in the early discussion. Divide lang natin yung standard deviation sa square root ng sample size. And since given yung dalawa, let's just substitute yung mga given. So, yung ating standard error now is equal to 10 divided by the square root of 64 or 8 yun. So, we will get 1.25. Now, anong gagawin natin doon sa 1.25? Imumultiply natin siya sa statistics in which, in this case, t-table yung gagamitin natin since population standard deviation is unknown even though yung sample size natin is greater than 30. In fact nga, 64 yung mga nakalagay dyan. And nilagay ko na dyan in bullet form yung mga critical values ng bawat equivalent confidence level. Sa 90%, the K value is 1.645 and kapag naman 95%, the K value is 1.960 and 2.57 naman, 2.576 naman if 99%. But take note, it varies depending sa degree of freedom, okay? And madidiscuss to mamaya. But for now, at least need natin na malaman yung mga critical values na yan. Kasi we will now determine kung saan nga ba magpo-fall yung population mean. So with 90% confidence, it will fall between 102.944 and 107.056. Paano nakuha yon? That is 105, yung sample mean natin, plus or minus 1.645 times 1.25. And if we want to be 99% confident naman, without increasing the sample size, the value will fall between 101.78 and 108.22. As mentioned earlier, need nating mag-sacrifice ng precision if you want to have a higher confidence and vice versa. In sum, the sample size is a function of the variability in the population, precision needed, confidence level desired, and type of sampling plan used, like kung simple random sampling ba yan or stratified random sampling and the like. Now, before tayo mag-jump sa hypothesis testing, balikan muna natin yung iniwan natin kanina. Let's now tackle about the trade-off between precision and confidence. I hope at this moment, medyo marami na yung knowledge natin about sa dalawang yan. Kailangan kasi gaya nga ng sinabi ko kanina, these are two issues na kino-consider in determining the sample size. And we have noted that if we want more precision or more confidence or both, the sample size need to be increased unless very little lang yung variability in the population itself. However, what if hindi na natin madagdagan yung sample size for whatever reason? Like, let's say, hindi na natin afford yung cost kapag dinagdagan pa natin yung sample size. Then, gamit yung same sample size, the only way to maintain the same level of precision is to forsake the confidence in which we can predict our estimates. That is, babawasan natin yung confidence level or the certainty ng ating estimate. Let's look on the illustration. This is an example of trade-off between precision and confidence. And kung mapapansin nyo, kanina pa natin na-touch. Iba lang talaga yung graphical representation natin. Pero dito kasi, mas makikita natin yung essence since ang bell curve or normal curve, yun, ang siyang pinaka-graph ng Z or T table. And ayun nga, sa bell curve A, ini-indicate that 50% of the time that the true mean will fall within the narrow range kung saan yung red dyan na shade in both sides or yung tinatawag natin na tail representing the 25% non-confidence or the probability of making errors. Contrary-wise, the bell curve B indicates that 99% of the 99% of the time that the true mean will fall within the much wider range, and there's only 0.005% that we are making an error in our estimation on both sides. In short, we have more precision but less confidence sa bell curve A, while high confidence but far from being precise sa bell curve B. Thus, it becomes necessary for researchers, para sa atin, to consider at least 4 aspects while making decision in the sample size needed to do the research. And ano-ano yung mga yon? So, number 1, how much precision is really needed in estimating the population characteristic of interest? That is, what is the margin of allowable error? So, in number 2 naman, how much confidence is really needed? Or how much can we take of making errors? In number 3 naman, to what extent is there variability in the population on the characteristic investigated? And last, what is the cost-benefit analysis of increasing the sample size? Kasi at all times, di ba, we need to consider the effectiveness, pero we also need to look for the efficiency ng isang bagay. Nagets ba yun? I hope so. And that would be the part 1. Part 1 pa lang yan kasi may part 2 pa tayo, and doon sa part 2, we will now deal on hypothesis testing and sa pagdetermine ng sample size. Bale, in this video, nalaman lang natin what is the precision, confidence, ginagamit yung sample data sa pag-estimate ng population parameter, and ito nga yung trade-off between the precision and confidence. So, stay tuned. Thank you.